when we discussed in chapter 3 moments, functions for the values. We discussed the different moments, the moments around the origin, characteristic function, non-genetic function, and we talked about the functions of random values. In chapter 5, we almost do the same, however, for two random values. So we talk about the joint moments, joint simple moments, joint moments around the origin, joint characteristic functions, and we define what we call the generally simple moments of covariance, correlation, which is one of the moments around origin. So let's go a little bit extension. So as again, reiterating what I said before, every chapter builds on the chapter before. So today we'll talk about, for example, chapter 5 will be, first of all, we'll review a little bit on the operation of single random variables, especially chapter 3. And then expected value when you have function of random variables, more than one random variable, x and y, mainly two random variables. We'll talk about the joint characteristic functions, and then we'll define what we call jointly Gaussian random variable. Very important concept. Extension of the single random variable, single Gaussian random variable. It's a very important concept for the use in Gaussian finite processes. So this is very important. And then we'll talk about transformation of multiple random values. Look at chapter 3, the transformation of single variable. When you have monotonic transformation, either increasing or decreasing, or when you have a general function. And we were able to find the PDF to CDF of x of y, which is equal to certain g of x. We'll do it now, however, for multiple random values. We'll talk about the for jointly Gaussian random variables, the linear transformation. This is again very important for this concept. The two concepts are highly tied together. Okay, this will be delayed later when we talk about in statistics. So basically, this will be lumped with statistics. Okay, problem.
Let's talk about the next chapters.
Yeah, باقي يعني لازم نقول إلى الآن اللي أخذناه. Chapter 1 كان introduction, how the definition. Chapter 2 كان single random variable, with PDF, definition, and so on. Chapter 3 كان operations on single random variable. تكلمنا عنه شوي. Chapter 4 was two random variables, with the PDF, definition, and so on. And then Chapter 5 are the operations on random variable and more. And this is basically the outline. The remaining is Chapter 6, which is introduction to random processes. Describe the random processes, how to describe the process, we define certain PDF and CDF and so on. Join PDF and CDF to define random processes, and then we talk about market process random processes, then how you the Gaussian random process. Because it's basically what is many. And in chapter 7, we talk about how to understand random processes in the time. We define logical relation as well. Understanding random processes in time. And in chapter 8, we understand continuously. And if we decide the NTI system for random process, what do we do? We have a value E15.
After the chapter, الأساسيات.
تمام. لكن هستخدم ما ينفع أساسيات كل شيء جديد.
تستخدم شيء.
هستخدم الرقم الأساسي. بعد كده هيكون في جزء statistics على جديد يعني. To indicate about the collection statistics, how to do type of system, how to do estimation of parameters. So in fact, then statistics will plan this in an IDP. Here we assume that we know the PJ. في statistics we assume we don't know. We want to estimate some parameters. We estimate the values. تقريبا هذا البعد الكورس. We are more than midway in the course. خلصنا أكثر من النص. إن شاء الله بإذن الله يكون متى وين حيكون؟ 15 عندنا 3 أسابيع. يعني حيكون I think chapter 5 we have enough time. Not many chapters, and mostly chapter 5 will be good. So it will carry higher weight than will be 20%. So expect the material to be chapter 3, 4, 5. Okay. So تقريبا هذا هو اللي أخذناه إلى الآن وهذا البلان أهل as we said. So we'll start today with some review on what we have done in chapter 3 about the operations of one random value. So basically, if we defined the expected value and we gave it this x bar, and it was expected value of x. And the way we calculate it for continuous value, for continuous random variables, we multiply the PDF with x and integrate. And for discrete, we basically add every value of x and give it a weight with its value. This is the way we calculate the average of random value. And we call the moment, our moment around origin, m sub n, which is expected value of xn. And the way we calculate it, very similar to the average, however, x to the power n next to the PDF. Okay? Similarly, in the discrete, x to the power xi to the power n next to the probability. And this gave us the moments around the origin. طبعا أهم المومنتس كانت هذا الافريج. What was a very important moment that we talked about? The various around the skewness basically. You expected value of x to the power 3. Right? And we also defined the expected value of x to the power 2, which is limited like this. If x was a voltage, the expected value of x to the power 2 would be by the power of the voltage. طيب, and then we talked about central moments. Central moments, we gave them a notation mu sub n, and it was basically expected value of x minus x bar minus the average to the power n. And hence it's central. Basically, you are looking at the every time you are comparing the value of x and xi with the mean, and this gives you certain value. You take it to the power n, multiplied by, give it a weight of the quality. So every time you are comparing the value of the x with respect to its mean, see, you plug them and you raise it to the power n. So for example, in the variance, what was n in the variance? 2. Mu 2, which is the variance. So basically, sigma x squared was equal to mu 2, which is the expected value of x minus x bar squared. Okay. So when you calculate it, every time you take a value x compared with the mean, so basically شوف كم الضرب الثاني هذا عن المين عن الأهلي, and you square, and you give it a weight equal to the probability of that x, and then you go to the next x. You take the value, the difference between كم بعيدة هي عن المين, and you square, and you multiply by its probability. Repeating this, what does it give you? It gives you the average distance from the value of x from xi minus x bar squared is the distance, the repeating distance. So if I have the PDF that looks like this مثلا, مهم مش بعرف افهم ايش معنى الاشياء هاي. خلينا نقول it's a Gaussian. Okay. This is x bar. So every time, in order to calculate this, we are multiplying x minus x bar squared multiplied by x. What I'm doing exactly is the following. I'm taking every xi, adding value, آخذ بينها وبين الديستانس اللي هنا. Okay, xi minus x bar squared. This gives me the distance square, something like that. And I give it a weight of the probability of this xi. Now I go to the next xi, xj. I repeat the same thing. I calculate the distance between xj and x bar and square it. This gives me the distance squared, multiplied by the probability of x bar, and so on. What is happening? Happening the average distance squared from the mean, which gives me the average distance squared from the mean. It gives me the average spread of the PDF. How spread is the PDF? Is it focused? Is it like this spread, or is it something? Sorry, or is it something that is extremely focused around x bar? الفاريانس هنا اعلى ولا هنا اعلى؟ ليش؟ لأن الافريج distance from x bar here is larger than the average distance from x. معظم the values of x are around x. So every time you have a distance that is smaller, given a weight that is larger. Okay? هذا خلينا نسوي chapter. All this was in chapter 3. And then we went through the characteristic function by defining phi x of omega, which is the expected value of e to minus e to j omega x. When you take the expected value of this, means that you are multiplying this thing by fx, by pdf and integration. And this is basically the Fourier transform. So this was the Fourier transform. And this, the PDF can be written as the inverse Fourier transform. Right? Similarly, the moment generating function نفس الفكرة كانت بس بدل ما نسوي Fourier transform e to g, we have e to gx sx whatever we call it. This is a dummy value. G is a dummy value. You can write as sx, which will be the Laplace transform. Right? And of course, taking the inverse Laplace transform, you can get fx from the moment generating function. And we call it the moment generating function because if we differentiate whether this or this and set omega to 0, differentiate it n times and set it omega to 0, then you get the nth moment around the other. Nth moment, how to find it? You need to integrate this, right? X to the power n fx. Even if PDF is simple, integrating this in general is not easy. So one way to simplify the whole moment generation is to differentiate the characteristic function or the moment generating function n times and set omega to 0. You will get much simpler solution. And then we went through the function of random variables. Okay? And we define when we have monotonic transformation and non-monotonic. In monotonic, basically, when you have here what? y equals t of x. When t of x is monotonic, means that it either increases or decreases. It doesn't go increase and decrease at the same time. So basically, y equal tx, t of x has 1, 0. In this case, the PDF of y equals the PDF of x evaluated at the image of, or the inverse of the inverse of y, multiplied by the derivative of the inverse. Absolute value. If you have non-monotonic, then you need to evaluate, you need to find the zeros of this equation. You will have more than 1 0, or 2 or 3 or 4. Like, for example, the x squared. Y equal x squared, how many zeros you have? So you have two terms here, because you have n equal to. What about the cosine? Y equal cosine 2 pi x. So basically, you have -2. Okay. So basically, very similar to this. However, you need to add many terms as many as the number of zeros for the equation y equal to x. Okay. So basically, this is تقريبا هذا اللي سويناه في chapter 3. Now we'll add to it in chapter 4. However, when you have two random, we mainly focus on two random values. However, the same concept applies up to 3 or more random values. So we start with the expected value of a function of random values. So for example, I have a function of two random values, g of x, and I want to find the average of that. Expected value of g of x and y. So g of x of y, x and y, call it z, equals g of x and y. Okay, x and y are random values. Okay, so call z as the function of the x and y. So z is what? It's a new random value. It's a new random value. So in order to find this, either you go and find the PDF of z. It might be easy, it might be complicated. And you have seen that if z equals x plus y, and x and y are limited, how do you find the PDF of z? The combination. So yeah, it's not something simple to find the PDF of y. However, an easier solution is to go and replace and put this next to the joint PDF. So very similar to what we have done, calculate the expected value of g of x. You're going to either you find the PDF of g of x, or you can just multiply g of x, whatever inside g of x, multiplied by the PDF of x, right? So whatever here just comes next to the PDF. Similarly here, expected value of g of x and y now goes next to the joint PDF of x and y and multiplied by d and integrate from minus to. Similar, this concept only extended to when you have x. Okay, Shema? Now we can see that the single running variable, what we've done here, is only a special case. Let's see. G of x, expected value of g of x. Now, if I have a function of x only, and I have the PDF, the joint PDF of two variables, x and y, then I put this next to the joint PDF. Okay? However, the integral here is what is the integration here with respect to x is the most important part, because y I can just separate it. So I can integrate with respect to x and with respect to y. So what is this? Marginal PDF of x. So basically, I can write this as in terms of g of x multiplied by the marginal PDF of x, which is equal to what we have done before. So you can see that this is a special case when you have to function of two random values. For generalization, you can have function of n random values. Similarly, you multiply by the joint PDF of the n value. This is the concept. What about if I have discrete? What do I get? Summation, right? So suppose that I am interested in expected value of g of x and y. However, x and y are discrete. What do I do? What do I do? Discrete random values. What do I do? Summation over I equal 1 over all xi's. Summation over all xi's. Summation over all yj's. And then g of xi yj multiplied by what? Probability of xi yj. Okay. So again, the value of the function at xi yj weighted by the probability of happening of xi and yj. Okay. Now let's see if I want to find the expected value of a sum of random values. So here I have sum of random values, alpha I xi. So call y as summation alpha I xi. I equal 1 Well, alpha I here is just constants. These are constants. Okay. Now, how to find the expected value of 1, which is the expected value of summation of alpha I. By using the concept of linearity of the expected value, we know that we can just put the expected value inside the summation. Then the expected value is nothing but either integration or summation, and you can replace with a summation. So basically, this is equal to summation of alpha I multiplied by the expected value of x individual. Okay. Now the proof of this is, and if you are interested, you can consider g of x1 up to xn as this expected value, as this summation, and then you write the expected value as the PDF multiplied by the. Right? So now, if I have n of these, what do I need to do? I need to write expected value of this function, right? Which is a summation of the many integrals, n integrals of the PDF here, alpha I x. Expected value. So now for every I, what is the integral that I have here? For every I am multiplying alpha I xi with this joint PDF. هل أنا أحتاج كل joint PDF هذا؟ For when I have xi only? All the integrals will give me what we call as the marginal PDF of x. So all this for the specific xi will boil down to alpha xi integral, which is the expected value of alpha I xi, which is alpha I multiplied by the expected value. باختصار, expected value when I have weighted sum of random variables is equal to the weighted sum of the expected values, the individual expected values. إذا عندي 4 random variables, معلش, alpha 1 x1, alpha 2 x2, alpha 3 x3, alpha 4 x4, then the expected value of them will be equal to the summation of alpha 1 expected value plus alpha 2 expected value is so alpha represents the weighting value. Alpha is just a constant. So here I'm defining y as summation of alpha I x. Alpha I are constants. يعني ممكن مثلا يكون عندي y equal a x1 plus b x2. Then in this case, what is the expected value of y? احنا قلنا دائما عندك two solutions. Either you go and find the PDF of one, and then apply the integral of minus infinity to infinity of y PDF. صح؟ صح ولا لا يا شباب؟ But I don't know this. So you can either go and find it using the concepts of chapter 3, which might be very difficult, or you don't use this equation. No, you go and use A expected value. أنت ما تهتم بال PDF of y. أنت only تبغى average. So you can go alpha expected value of x1 plus E expected value of x2. مين أسهل؟ هذا حلو ولا هذا؟ مرة سهل لأنه you can find this. It's a number. This is easy to find. This is easy to find. You have the PDF, but PDF of y in many cases not easy. زي ما قلنا يعني إذا if you are lucky that this x1 and x2 are independent, then you will be able to use convolution. But if they are not independent, you need to go and do integration. هذا الرسم تذكروها. You need to do this integration, which is extremely, in many cases, extremely difficult. So this whole concept here is to simplify the. Chapter 5 will give you ways to simplify the way we calculate PDFs. Sorry, we calculate the values for more than one. Well, the same definition as we did before, you can do the same. He had moments around origin or single random variable, and central moments or single value value. Now we can have what we call joint moments. نفس الفكرة. الjoint moment will be expected value of x to the power n, y to the power k for certain n and t, which will be this x to the power n, y to the power k multiplied by the joint period. Now, if you have a discrete, what do you get? Summation again, x to the power n, y to the power k. If you have discrete, you have summation over xi again, summation over yj, what xi to the power n, yj, every value to the power k, multiplied by probability of xi, yj. You have discrete.
N1K from like
Yeah, m and k are positive numbers.
Yes, from where to where? No, I mean the
In summation, you mean?
yes,
No, you are summing over all values. Isn't it clear what I'm saying here? I am summing over all values. I mean, this is a summation over all values. X takes. هذا معناها. So basically xi. Okay. وهنا I am summing over all values. What? Y takes. Which are y. هذه هي فكرة summation over x values. Right? Now, and we call this as m sub nk. Now, now let's see different values of n and k. When k is 0, what do I get? I get y to the 0, which is 1, and expected value of x to the power n, which is the nth moment around the origin of x. Right? Now, while if I put n as 0 and k any value, n0 will be x to the power 0, so x disappears, and I have only the kth moment around the origin of y. Now, we call n and plus k as the order of the moments. The single random variable, m sub n was the order. Over here, we have n and k. So n plus k is the order of the moment. Now, we go second moment, the single random variable, it's the expected value of x squared. Huh? Here, when we say second joint moment, you don't have 1. You can have 2, 0, 0, 2, or 1 1. كل هذه تعتبر second moments. كل واحدة لها معنى. هنتكلم عن معناها بعدين. Okay, so basically second moment here, this, and this. Now, what is this? This is expected value. What is this, Shibah? Expected value of x squared, right? What is this? Expected value y squared. نعرف إيش معناها. Right? What does this mean? Average تقريبا باور خلينا نقول إذا هي voltage أو mean square value. وهذا mean square value of y, هذه of x, هذه of y. But what about this one? X, y. هذا نسميها correlation. هذا نسميها correlation. Correlation gives you on average how much x and y are related. Related معناها they go together or they go increase together or decrease together. نتكلم عنها. Okay. Now the first order, when we say first order means what? n plus k equals 1. So either you have n equal 0 or k equals 0. Right? So either n equals 0 and k equal 1, which gives you the expected value of 1, which is the average. Right? Or n equal 1 and k equals 0, which gives you expected value of x or x bar. Okay? So now if I have a joint PDF, okay. فتذكر الجوينت PDF كيف رسمناها؟ كنا نرسمها كذا صح؟ This is x, this is y. وهذه كانت PDF x, y. Right? I'm not a good drawer, لكن في function معين. It's a surface لو تتذكروا كانت صح؟ Then in this case x bar y bar will be like the center of gravity of this surface. إذا هذا السيرفس يصير كأنه شكل ما أدري. نرجع على one of the slides in chapter 4 to be easier to visualize. نتذكر فكرة السيرفس الجوينت PDF. This is a joint PDF, a typical joint PDF, right? Then in this case, this will look, if this is X bar, X bar is here. If this is X bar, okay, and this is Y bar, then this point هذه النقطة اللي في النص هذه كأنها السنتر اوف جرافيتي. انت you have a surface. السيرفس هذا ايش يشكل لك؟ فوليوم صح؟ ايش اللي تحت السيرفس؟ ايش شكله؟ ايش نصنفه ماثيماتيكلي؟ فوليوم رايت؟ كأنه صار عندي شكل، كأن عندي صار 3 dimensional thing. Now this 3 dimensional thing is center of gravity حقه مكان تركز الكتلة is where x bar is at the point of the average of x and the y average of x. هذا هو مكان تركز الكتلة. ايش يعني مكان تركز الفيديو؟ مكان تركز البروبابيلتي اوف 1. توتال هذا لا تنسى ايش كانت تعطينا كيف التوتال بروبابيلتي اوف 1 distributed among x and y صح؟ So basically x bar and y bar were the center of gravity of this shape or this volume. طيب؟ Any question? طبعا. لا يعني الفوليوم ايش يحتاج؟ الفوليوم يحتاج عندك الفوليوم عباره عن ايه dimension صح؟ So I have here the x dimension and the y dimension and the PDF dimension. اللي هو ايش البي دي اف؟ ايش الاكسس هذا؟ هذا يعطيني how is this probability of 1 distributed among different values of x and y اللي هو السيرفس هذا. الان السيرفس هذا combined with x and y gives you like a volume. الان وين تركز ثقل الفوليوم هذا؟ كتلته وين؟ مركز الثقل وين؟ at x bar and y bar at this point. هذا اثقل، هذه اثقل نقطه. ايش يعني اثقل نقطه؟ معناها المكان اللي فيه اعلى probability. Okay? Which makes sense, it's the average place. طيب؟ تفضل. هاي هيتكلم ما تقول ينفع لكن لما يكون عندي ضمن الفن ما تقول هيتكلم عنها هذا يقول ان شاء الله. اوكي؟ في هنا طبعا احنا we are only defining الاشياء. لو تلاحظوا كل اللي سويناه الى اليوم يعني تقريبا كان 3 سلايدز ولا يعني 3 سلايدز الباقي كله كان مراجعه. We only define things. So until now we did not give examples, we did not talk about the different special cases. So here we defined the expected value of a function, and then we defined the expected value of a weighted sum of random variables, and then we defined the moments around origin with certain order n plus 2. الآن حنتكلم بعدين في تفاصيل عن بالذات هذه حنسميها correlation ايش معناها and how to calculate it and when we can decouple. وحنتكلم بعدين عن central moments how we define what we call covariance متى decouples and so on. الآن let's focus على الفكرة هذه اللي هي ال M11. Let's focus on this. This is very important moment. يعني M21 M20 M02 ايش قلنا هذه عبارة عن ايش كانت اشباه؟ expected value of x square. هذا expected value of y square. This gives you how much خلينا نقول power او mean square value of x. وهذا mean square value صح؟ وال M10 و M01 give us what? Average of x with average of y. So we understand الآن the role of this. This is the average. We understand the meaning of these two. The mean square value of x and y. وهذه average of x and y. And we need to understand what M11 gives us. This is a very important moment, and we'll focus on it shortly. This is زي ما قلنا by definition equal expected value of x multiplied by y. And we call this as the correlation of x and y. ايش يعني correlation? أول شيء how we calculate it. We calculate it using the lead. طبعا we give it a special lead. مثل variance. variance كأنه اسم sigma x square. variance. الآن لما تشوف Rxy means that this is a correlation between x and y. This is equal to the expected value of x and y. And the way we calculate it, we take x and y next to the joint figure. So eventually, what are we doing? خلينا نروح على discrete case. In discrete case, it's easier probably to quantify and explain. So this is over summation over all values of x, summation over all values of y, right? And then what's left? xi, yj multiplied by the probability of xi, the joint probability, and yj, right? So what are we doing here? We are multiplying every value of xi by every value of yi, and we give it a weight of the probability that this pair xi, yj happen. Okay? So if this pair happens more frequently, it will get higher weight. If this pair happens less frequently, it will get smaller weight. Okay? So eventually, Rxy will give you the average. هنا تعطينا average. This basically gives us the average. The average of the relationship between xi and yj. يعني خلينا نقول إنه مرات خلينا نقول for high frequent xi yj. If xi is large and yj is large, what do we get here? في الترم هذا ايش حيطلع هنا؟ If this is very high frequent pair, xij, yj, and xi and yj are both large, what do I get? Large number, صح? الآن if we have a high frequent pair, however, xi and yj واحد منهم صغير والثاني كبير, what do I get? Smaller number, right? What about if both of them are small? I got even a smaller number. What about if I have a large xi and large yi, like small, low probability, less frequent? I get smaller number. So what you can see is this correlation gives you the average amount of how xi and yi are similar. ليش؟ لأنها تكون كبيرة متى؟ لما هذه very frequent و xi and yj are both large or both small negatively. لكن for small values xi and yj, even if they are frequent, you will get a smaller portion. لكن for large values, however, even for less frequent, you will get also small values. So you can see that this gives you the average similarity between xi and yj. ليش؟ لأنه هذه بتكون أكبر. ليش؟ لأن pairs that are of the same magnitude اللي قريبة من بعض. إذا واحد منها صغير والثاني كبير بتكون شوين. صح؟ So this gives you the average. This gives you the average similarity between xi and y, between x and y. Okay, between x and y. Average similarity. هذه نسميها correlation. Average similarity is correlation. Higher similarity means they are highly correlated. ايش يعني correlated؟ الكلام باللغه الانجليزيه. Related ايش يعني؟ مرتبطين. Correlated means مرتبطين مع بعض. الكور دائما تستخدمها لما يكون شيئين مع بعض basically. So correlation means that they are هي ما هي correlation هي correlation. بس عشان نحدد يعني emphasize كلمة core here. Correlation means that they are together. The relationship between x and y. The higher are xy in the positive side, the larger they are similar. The higher the x and y in the negative side, ايش هذا يصير؟ The more similar واحد the negative حق الثاني. The more similar x to minus 1 and y to minus x. واضح؟ If you have very positive, large positive means that they are correlated, highly correlated. لهم علاقة ببعض. يتغيروا مع بعض. إذا large negative, what do you get? x يتغير علاقته كبيرة مع minus y and y علاقته كبيرة مع minus x. طب what about if you have close to 0? Not correlated. إيش يعني؟ ما لهم علاقة ببعض. واحد يتغير independent أو قريب من independent من الثاني. ما له علاقة ببعض. ما له علاقة قوية ببعض. أوكي؟ متى يصير 0؟ لما for the high frequent or low frequent, these two things are always different. واحد كبير والثاني صغير، واحد كبير والثاني صغير. يكنسلوا بعض. دائما تطلع لك الفاليو صغيرة. واضح؟ طبعا الآن we can write expected value of x, y as expected value of x multiplied by expected value of y. متى هذه نقدر نسويها يا شباب؟ نعم؟ لما يكون ايش؟ independent. أول شيء خلينا نشرح واحدة. Let's say expected value of x, y. And here x and y independent. Okay? Let's see how it looks like. What is the definition of this, Ishbak? Double integral, right? Of x, y, PDF of x, y, join PDF, right? dx, dy. But they are independent. What happens if they are independent? Now, we can separate them. Basically, we can have minus infinity to infinity. And we have what? Fx alone. And we have Fy alone, right? Dx, dy, and we have x and y. Now you can see that you can decouple هذول لواحد وديكابل هذول لواحد. Simply there is no relationship. You have double integral. You have double integral. How about x, fx alone, y, dy alone? So basically, as if I have what? I can separate the integrals. Basically, I can have minus infinity to infinity, x PDF of x multiplied by this is alone. Another integral minus infinity to infinity. What? PDF, sorry, y, PDF of y, exactly. But what is this? What was this equal to? The average expected value of x. What was this? Expected value. So if the two random variables are independent, they are independent, expected value of xy equals expected value of x multiplied by expected value. I can decouple it. Okay? That's our point. Now, if I don't know they are independent, أنا والله رحت جمعت الداتا, many values of x, many values of y, I calculated this. And I calculated the average. I know the average of x, I know the average of y. Well, if expected value of xy equals the product of the two, means we call this two random values are uncorrelated. انا ما اعرف ما independent ولا لا. ما اعرف independence ايش يعني يا شباب؟ Independent is a very strong condition. The joint PDF equals the product of the margins. This is very strong. لكن هنا did I calculate the PDFs? No. Sometimes I حتى ما اعرف ال PDFs الشكل. ف I collected certain data. I found that the expected value of XY equals the product of the means. In this case, we call these two random values are uncorrelated. الآن from here and from here, it's very clear that if I have independent random values, they are uncorrelated. لأنه independence will guarantee that the expected value of XY decouples into the two means. صح ولا لا? So independent means that they are uncorrelated. What about if I know that they are uncorrelated? Can I get a conclusion about whether they are independent or not? I'm not sure on PDFs. I have no clue how is the joint PDF related to the margins. So uncorrelated, المعلومة اللي تجي من uncorrelatedness has nothing to do with the independence. I cannot conclude. Yes? Because uncorrelated means this is valid. This equation is valid. But this equation is valid did not tell me that PDF equals the value. The product of the margin. من وين عرفت من هنا الجوint PDF decouples into the margins? How do you know? لا تألف. This can happen in many cases. Regardless of أقول لك مثال expected value of XY equals 0 and one of them is equal to 0. The average. واحدة من two random values equals 0. اللي average حقها. You get this satisfied uncorrelated. هل معناها انهم they have margin الجوint PDF decouples into the margin؟ ممكن لا ونفهم. هي الفكرة انه independence leads to uncorrelated بينما uncorrelated does not lead, not necessarily. This does not lead. The opposite is not necessarily. مكتوب تحت. Not necessarily. It might be, it might not be, we don't know. So basically independence, لو تلاحظ independence means that joint PDF decouples into the marginals, which leads to correlation decouples into the means. لكن correlation decouples into the means does not give us any information about whether the joint PDF decouples into the marginal PDFs. Okay? That's really the tendency. Later we'll show that if you have Gaussian, then uncorrelated guarantees independence. لكن يعني لا تستعجل عليها. Now we call Rxy, which is the expected value of xy, equals 0. We call these two random variables R orthogonal. So we have uncorrelated when expected value of xy equals the mean, sorry, the product of the two means. But if it is equal to 0, we call them orthogonal. Okay? And by this, I need to stop. Next time, inshallah. Continue. We talk about the quiz, chapter 3. Okay? Probably we'll have another quiz the week after. Probably Sunday, okay? Chapter 4. So that you prepare yourself for this. نعم؟ I'm just saying. I try to start to get prepared. Like not necessarily like middle or even the end. Thank you very much.